Work functions of surfaces and interfaces can very naturally be calculated with our periodic DFT code band due to the support of true 2D periodicity. 2D periodicity means that there is no periodic image above or below your slab model. This would not be the case with plane wave codes. Since there is no vacuum gap or any other correction needed, the work function simply equals the Fermi energy. Let's calculate how the work function of a bare aluminum 100 surface changes when a thin film of lithium fluoride is deposited on it. For this, we calculate the work functions for both systems and compare the difference. The demonstration is based on a step-by-step tutorial to which I will put a link in the video description. We begin by importing the aluminum surface into AMS input. In the band main panel we select the PW91 functional before clicking on the details panel for numerical quality. Here we will request a 7x7 K-space grid and a couple of settings to help with SCF convergence. First select the Becky grid and good quality for the density fitting approximation. Click on the details button next to K-space and enter 7-7 as the number of points. Next, go to the SCF menu and select 0.002 Hartree as the electronic temperature. Save and run the calculation. On a reasonably modern computer this will only take a couple of minutes. Once the calculation is finished, we can find the Fermi energy in the output file. The work function equals the Fermi energy, so in this case the work function becomes 4.44 electron volt. Now let's repeat the calculation with an aluminum lithium fluoride solid-solid interface. Again, the structure is provided by the tutorial alongside instructions on how to create it with the GUI. But for now we just import this structure and save the calculation under a different name but with exactly the same calculation settings as before. Again we can find the Fermi energy printed in the output file, and a comparison between the two work functions shows that the lithium fluoride thin film has lowered the work function by 0.42 eV. The calculated values compare well with the literature reference by Prada et al. So that's it for today. I hope you found this useful, and as always we are happy to answer comments and questions below the video.